In this video, we're going to be going over texture sizes in a process called Mip Mapping. So in this Photoshop document, I have some really commonly used texture sizes. And you'll kind of notice from previous assignments that I've always just given you arbitrarily a texture size, and I wasn't just randomly picking a number. There's kind of a reason behind that. All of the texture sizes that we've used have been what's called powers of 2, or kind of numbers that you can keep dividing by 2 until you get to 1. So again, here's some common texture sizes. So we'll just start at 1024. So if we were to divide this number by 2, divided by 2 equals 512. So again, I'm grabbing this texture size, I'm cutting it in half vertically, I'm cutting it in half horizontally, which will reduce the size by 1/2, reduce this size by 1/2, giving us 512. So a 1024, when it gets effectively scaled down 1 or divided by 2, it turns into a 512 texture. We do this again, divided by 2. Now it's going to be a 256, divide by 2, 128. And again, we can keep doing this process over and over again, and we keep getting whole numbers, so not any fractions, divided by 2. Just keep doing this for 2 divided by 2 is 1. So these numbers are kind of magical as far as 3D goes because they can keep going down and getting smaller and smaller and smaller until they're just 1 pixel in size. And another thing I just want to iterate is that this 512 texture, for example, it's not half the size of this 1024 because it's getting cut in half effectively twice. So vertically, so up and down, it's getting cut in half, and then horizontally, it's getting cut in half. So technically, a 512 texture is 4 times as small as a 1024 texture. So we don't necessarily always have to have a perfectly square texture. So in this, I have kind of 2 folders going, so I'm just going to hide this one and turn this guy on. And inside here, these are more irregular textures, but they're still powers of 2. So this one is 1024 wide by 512 tall. So if we were to divide this by 2, it would then be 512 by 256 divided by 2 again. And again, since each of these numbers is a power of 2 individually, we can keep dividing them by 2. So just another example is this one is a 256 by 512, so it's taller than it is wide. This texture might get used for something like a sword in a game where you have a really long blade. This guy right here is really, really wide, so it's a 512 wide by 128 tall. So again, you can mix and match these powers of 2 all you want, and they can keep dividing over and over again. Pretty much any other number that's not a power of 2, it could be an even number, like 144, for example. 144, if we divide that by 2, we get 72, so it goes down once, divided by 2 again, 36, 18, 9, and now if I divide it by 2, it's 4.5. We can't have a half of a pixel, so this 144 example stops at 9. So again, just some simple math for you, but just know you can have square textures like these ones I had shown, or you can have more irregular textures like these ones that aren't perfectly square. But again, both numbers, horizontal and vertical, are both powers of 2. So turning the non-square ones off, just some common phrasing that you'll hear when people are working with textures is normally these smaller ones, they'll just refer to this as a 128 by 128 texture, or a 256 texture, or a 512 square texture, or something along those lines. 1024 textures, depending on kind of who you're working with, some people will actually call these a 1K texture, so 1K is 1000. So let's jump up to slightly larger textures. So now we have a 1K, or if I was to look at the number of pixels here, it's kind of deceiving. This is 1024. So again, this image looks really similar to this one. So let's just go ahead, flatten this image, bring it over here, just so we can kind of see what we're working with. So again, this guy, so we're really, really small here, is our 1K. We started all the way down at 128, 256, 512, 1K. We'll turn this guy off. Really don't need that layer anymore. We'll just go ahead and delete that. So then this one would be a 2K, or 2048 by 2048. So again, this one 4 times as big as this one. And this one is a 4K texture, or 4096 by 4096, or 4096 pixels. So again, you can kind of see the texture resolution here. When we bump up from a 1K to a 2K to a 4K, we're getting just an obscene amount more pixels. Because again, 128 compared to a 4K, there's just really big size difference going on here. So with that bigger size difference means I get more pixels or more resolution in the 4K texture. So that means that whatever I'm painting, whatever textures I'm applying, I can get more detail in a 4K texture than a smaller texture. And again, usually you want the most amount of detail possible, unless you're doing something stylized where you have a lot of solid colors. So real quick, I want to address a common misconception when it comes to 4K textures. So a 4K texture and 4K resolution, like when you're going to buy a TV, you'll get a 1080p TV or a 4K TV. There's a difference there. So let's look at this real quick. So this square right here, this big one in the background, this is our 4K texture resolution. So it's 4096 by 4096 pixels square. This one right here is your 4K TV resolution. So it's not actually 4,000 pixels wide, it's almost 4,000 pixels. It's 3048 by 2160. So again, it still has that kind of movie aspect ratio, not going too much into detail about this. And then your 1080 resolution is smaller. So again, this is 4K resolution because it holds for 1K resolution. So 1, 2, 3, 4. So again, a 4K texture is not a texture made for a 4K TV, or it's not the same resolution as a 4K TV. It's just coincidental that both of them are commonly used around the same time, and this one's about 4K, this one's about 4K, and they're both referred to as 4K. So just getting that difference out of the way. So now for the big question of why is all this powers of 2, square textures, non-square textures, why is this important? So in the beginning of the video, I had used the term Mip Mapping, and that's kind of why all this stuff is important. So what Mip Mapping is, let's just go to PolyCount, again, really good resource. So Mip Mapping is the process of taking a texture in-game and kind of automatically scaling it down. So again, you can think of this as a 1K texture, 512, 256, etc., all the way down to 1 pixel. And the reason why this is so important is because a game engine can actually naturally just scale down and use a smaller version of the same texture over and over and over again. So let's look at an example of this. So this would be a random environment. You can see there's mountains in the background. This is just kind of the ground plane you'd be looking at. So here we have these same numbers we keep seeing over and over again. So if something is closer to the camera, you're going to be able to see it better, just like if something's closer to you in real life, you can see it better. So we're going to give that a larger texture. And then as it gets farther away, even if it's the same thing, instead of having really big texture, so using a lot of texture space, we're going to kind of naturally bump that down to a 512, and then it gets farther away and we bump it down to a 256. So this is something that as a 3D artist you need to be aware of kind of how it works. But these distances and texture sizes, they can be kind of varied up in game. So again, when we get farther and farther away, it goes 512, 256, 128, 64. This little guy's 32. And then up here, because this 32 is at a glancing angle, the mountain is kind of facing us again, so we're just going to bump that texture up a little bit. And again, this can be different from game to game. So we're going to go ahead and take a look at an example of this. And the example we're going to use is actually from this artist. I'm not going to butcher her name, it's not English, but senior 3D character artist at Riot Games. And this is the example we're going to be taking a look at. So jumping into Modo, this is that exact same model. So let's go ahead and make our UVs, our texture visible. So we have our texture selected. Options, backdrop, currently selected image. And if we zoom in on this, again, there's some pixelation happening because, again, this is only a 1024 by 1024 or 1K texture. And again, you can see the texture over here. We could bring up the unwrap. Not really necessary, but again, we have some mirroring and overlapping going on. So let's look at this in full screen, turn the wireframe off, and I'm actually just going to change this to textured so we don't have any lighting in the scene. So again, really beautiful example of nice textures on a character, but if we were to zoom out and we were really far away from this character, like this far away, I can't see her pupils, I can't really even see her necklace anymore. She's just really far away, so there's really no reason to have a 1K texture loaded into the game. So what we can do is I just have these textures just kind of pre-made, where there's a 1024 version, a 512, 256, 128. They're just smaller versions of the same texture. So if I go through and just hide these, so we're at the 1024, this would be the 512. Again, a little bit of pixelation happening, so we can compare smoother, more pixely. 512 turned off, so now this is the 256. Again, we're losing a little bit of detail, but it still looks nice. And then the 128, this is where it really starts to lose detail, and it wasn't really ever intended to be this small. So to kind of make this example work, we're going to zoom out about this far. So we have our 1K or 1024 texture turned on. Let's go ahead and turn that off. And again, from this distance, we're not seeing really a difference when I toggle this on and off. So that kind of tells you that as soon as we get, let's say, 6 meters from the camera, we could Mip Map down one level on our texture and not really notice a difference. Again, if we have a 512 texture loaded in instead of a 1024 texture, we're saving on resources. So if we were to step down one more time, so turning off the 512, this is the 256. So again, if I was to zoom in, I can tell a pretty big difference between these two. But as soon as she's, let's say, 6 meters away from the camera, and I turn this on and off, there's a little bit of a noticeable difference, but it's not much. As soon as I make her just a little bit smaller, so she's an extra, let's say, 4 meters from the camera, so it's rolled 10 meters from the camera, I'm not really seeing a difference here. So we could now have a 256 texture loaded in. So let's turn off the 256. So this one, we're really losing quite a bit. The chest, where this line is, this kind of the seam of her shirt, and then the necklace, both of those are starting to look really pixely, and she loses a lot of information in her eyes because, again, the 256 is 4 times larger than the 128. But if we get, let's say, 20 meters from the camera, now we really can't tell a difference. I pop on the 1024, turn it off. We're seeing a little bit of like a flicker of change, but not really enough. So that's why powers of 2 are so important, because again, we can start from a large texture and then just kind of easily, mathematically accurate step down again and again and again, or step back up as we get farther away from or closer to the camera. So again, Mip Mapping, really, really powerful. It's an industry standard that you should definitely take advantage of. And hopefully this lesson has been a good insight to why we use powers of 2 for textures.